So, hi everybody. Again, my name is Noam. I'm coming from eToro. As in the video, my main work in eToro is around CI/CD infrastructure, CI/CD and infrastructure as a code. First, I want a big applause to my wife that allowed me to come here during a school vacation. Okay, she will probably see the video. She had to deal with 2 little boys alone home. It's very difficult. Before we start, let's understand what is eToro doing. We are in fintech. Everybody knows what the meaning of fintech? Someone is not knowing the fintech terms? Okay, finance and technology. So a little bit about eToro to understand the world we are living in. So our vision is opening the global markets for everyone to trade and invest in a simple and transparent way. Our mission is to building the world's leading social trading network. We have a special platform for that. And few of numbers we have. We have 10 million registered users. We have clients from, I think, more than 140 countries, 280 million open trades at the same time. We are 150 employees, and we have raised capital of $162 million. These are a few screenshots from our platform. Here we can see on the screen stocks and cryptocurrencies, ETFs, and much more that you can trade through our platform. The social platform is the copy people. This is what we are best of. You can put money that on other people in the system, and every trade that that person does reflect on your portfolio as well. So if you think that person is doing well, you can see his trades, what he's doing in his portfolio, you can copy it. And it will be reflects on your portfolio as well. Everything is transparent. You can see everything people is doing or doing. And last thing is in portfolio, invest in copy found. It's sets of instruments like bank market stocks or cryptocurrencies, and together, and you can put money on that, and our machine learning will choose what to invest in, when to buy, and when to sell. And it's supposed to be with, it is with machine learning. So in order to achieve those goals and the number of users and trades, our infrastructure distribution is, we have one on-premise data center, state in London. We just closed one that was in Amsterdam, our DR site, and we moved it to Azure. As you can see, we are spread on 4 different Azure regions, West Europe, North Europe, and we just entered in the last year to the United States, our new market there, West and East. Our best code is mainly .NET, Microsoft .NET, a lot of limitation that we'll see after that make us choose those solutions. We are just migrate our code to .NET Core in order to benefit with the new Docker world and the Kubernetes and move our base code to run on Linux. But it's just in the start. We're just moving the code. And our client side is developed with Node.js. And of course, we have much more. Those are our CI/CD tools. Jenkins, as everybody familiar with, of course. We have Puppet for configuration management. We also use Ansible. We are Microsoft Workshop mainly, so we use PowerShell. And we have Bash because we have infrastructure service Ubuntu and Node.js application that install on Ubuntu, so we use Bash and Ruby as well. Actually, Ruby we use because 5 years ago someone thought that Ruby is cool, so why don't write some infrastructure scripts that we need in Ruby? So we stuck with Ruby. And Windows and Ubuntu. We are trying to choose the right tool or scripting language to the mission or to the task we need. We can choose Puppet, we can choose Ansible. It depends on what we are doing at the moment and what is suitable the most. Okay? So agenda, we have 3 challenges here, and those challenges came for our growth. With the growth of the clients and the spread around the world, we had to develop more. We have more applications, more features, and with that we hire more people, more QA persons, more developers, of course marketing and accounting and whatever, but Here we're speaking about the technology. And with that, we have the first challenge in development QA. Each new developer, each new QA that want to work with the end client product, he wants his own separate environment. And we weren't dealing with that before. And now, each week we have a new QA that want to work right when he's coming to work. The first day, the second day, I need a new environment, a new VM, a new something, I want to start working. The other one is QA automation. When you spread that much, when we have hundreds of applications and features and you want to test them, you have to go automate everything, including your test. So how do you run the QA automation in fashion time? Okay. And at the end, the production readiness. We have 4 different regions in Azure, and we have another in on-premise. We want to put our code closer to the clients as possible, and we want to do it easily, efficient, cost-effective, fast, and easy to maintain. So how do we do that? So let's try with challenge 1 and development QA personal environment. So as I said, we are growing and we have growing number of QA person, and as for now, each person of our end QA manual and automation need 4 servers. Maybe tomorrow they will need 5, but tomorrow is Friday and we will not working on Friday, so we have to wait to Sunday. But we have 1 server for checking your code with the integration environment, APIs and servers and database and everything. We have 1 to test in staging, and they want 2 in production. 1 for manual testing, and 1 to run the automation scenarios that person wants with production settings. So we started with VMs, and we have limited number of VMs. First, before it's high cost. Maybe you don't have to as the first problem if you have money, but it's still high cost. And is a bad resource management, because the infrastructure team, or in our case, it's the production team that's responsible to the development and the QA environment. They are the ones that need to create those VMs and configure them and make Puppet or Ansible, depending on the software, to install that and to know it and to automate the entire CI or only the deploy for the QA guy using the Jenkins. And in our case, our developers and QA are still not have full control of Jenkins jobs. So we have a bottleneck that is our infrastructure and production team. And that is bad resource management. So new employee engagement looks like that. They're coming to work and they wait. And the solution for that matter was blocking on Kubernetes. Because our client is a Node.js, we said, this is Node.js, we already have it on Ubuntu servers. Why don't Dockerize it? We already tested, we know it's work. So why don't Dockerize it and put it on Kubernetes? That Azure just released the Kubernetes manager of Azure, the AKS, so why don't do it? So this is the solution. How many people are using Kubernetes already? Okay, half of them, that's good. 6 months ago or 1 year ago, no one. So if you can feel okay with that. Okay. So why we choose Kubernetes on Azure? First, because we're working with Azure, so we didn't have much choice. But second, it's managed. If you heard stories or if you try to upload Kubernetes by yourself, you can see and know that it's not a very easy task. So it's managed, and it's not our business to making infrastructure or making CI tools. Our business is finance on technology. So we're using the managed solution AKS. It's dynamic scale, of course, Kubernetes. Otherwise, why use it? And it's simple deployment. With only 1 or 2 templates and few CLI commands, Azure CLI commands, you have your cluster running and working, and it's a matter of minutes, really, few minutes, Amir is that is coming. Amir, raise your hand. He's the one that uploaded the Kubernetes cluster few times. And this is the architecture of how the solutions look like. I just show you that, and we drill down a little bit to understand each component of that. But does someone know what is DG refers to? Anyone? Okay, this is the initial of our QA director, Dan Gannon. So when we presented to the management, I put this is his photo. He doesn't have photo in our system. So when Dan Gannon wants to enter his personal environment, isolated environment, which is the client side, developed in Node, he enters in the home probably the URL that he's just been given from the job he ran. It's directing to the Azure proxy that we have. Is a solution that we already had from production. So we're using the same solution there. The Azure proxy sees that DNS and the domain and route him to the traffic that you probably already heard about in a few other sessions here, right? Everybody heard about that? Yeah, somebody didn't hear about that? Okay, only one, two, great, okay. I'll talk a little bit about that. Okay, so the traffic is seeing the domain, the DNS, and okay, you are Dan Gannon, this is the URL. I'm going to use the Kubernetes service over here and direct you to the exact pod where you just deployed your container. Okay, or everybody familiar with the term pod and containers? Anybody is not? Great. Okay, so let's drill down a little bit. So using the services inside the Kubernetes, we set service, and this service is attached to a specific pod, the one that you just deployed. Inside that pod, we have two containers that are our website that we want to test. We use ingress object as Nginx, and the ingress controller is the traffic. Okay, that he will know how to direct each DNS to a specific pod in our system, and this is how we isolated those DNS. And if something is being changed, you just need to deploy. And you deploy only the configuration, a matter of few seconds, and you have a new settings there. If one of the Kubernetes nodes is being deleted, I don't know, overeat, I don't know, something, traffic and the service and this ecosystem will keep you going and keep you working on the same platform. So this is traffic, a reverse proxy load balancer that's easy, dynamic, automatic, fast, full-featured, open source, production proven, and so on and so on. So no wonder it's so popular. We're not using that still in production, but we probably will when we get there in production as well. So we want to deploy we have a new employee or existing employee that want to upgrade the version, change the version. This is the pipeline, the initiate pipeline in Jenkins. You need to insert the tag in GitHub. Everybody familiar with the with the tags in GitHub? You have branches, but you can, on the branch itself, you can tag a point. So usually they are working with tags in our client. So we need to enter the tag. They need to enter the tag asset, those two containers, a version that is being injected into the front configuration as well, because you support few version for the site. And then you need to choose the environment. Those are the four environments: integration, as we said, staging, production, and production 2. When you choose this in the specific environment, you get a specific DNS. We'll show it. You get a specific DNS that is from your user ID that is connected to our Active Directory. The Jenkins is connected to the Active Directory we have. And so you have the user ID .int dev prod or -2.prod. And this is not a real DNS, of course. And first, you know exactly what is the DNS, the URL that you are going to receive, so you know what you should check. And of course, you will get the notification of that either in the Jenkins job when it's finished or by mail. And then you can browse to your own isolated site and by a matter of minutes. So this is how the pipeline looks when we finish. We have the build images, front and the asset. We have upload to Kubernetes, send mail, of course, and we're done. Is anyone knows how can we reduce dramatically this pipeline time? And this pipeline took only 3 minutes and 22 seconds. What can we remove from here? Anyone? Sorry? Exactly, yeah. We can remove this build images step and build it separately on a different stage or different process. So when? For each commit. We are located in GitHub, so we can set a webhook that on each commit, each new tag, branch, commit, we just send in a webhook a command trigger to Jenkins, please build me and 2 images of that tag, and put them on any Docker registry you are using. We are using Azure Docker registry. We're not doing that yet because of the capacity. We have a lot of tags, a lot of branch, a lot of developers working here, and Azure have a limited storage in their Docker registry. I hope it will be open someday, but we're afraid it will be out of space. But we consider that as well, maybe limited the time images inside the Docker registry for only 1 or 2 weeks, and then deleted it, and then we can dramatically reduce the time it takes to deploy for, I don't know, 1 minute overall, a few seconds. So as I said, if user get this DNS, here we can see a dashboard of our AKS Kubernetes. Here we can see only 10 pods out of 32, and you can see, and I'm not sure if you can, but this is the user ID, the name of the users. This is the environment, and this is the environment they are working with, the configuration of the environment. And that configuration, by the way, is not inside the code or the configuration files of the website, is actually coming from the Azure proxy. Okay, in order to avoid domain, forgot the name, domain issues and cross-domain. So we're using the same domain always, and just the website is using this relative domain, just add the API is using. And inside the Azure proxy, we have few pools that recognize the domain you came with and direct you to those APIs. Those APIs are for each environment separately. And here again, we have the Azure proxy, we have the services and the pods, and we can create as many as we want new pods. So each new employee that comes and wants to start to work on these sites, a new site, can just need permissions to run the job, and that's it. He's got his own separate environment. So the benefits are self-service. As we said, we don't want bottlenecks. We don't want that everybody will come to our section that you saw in the previous video, and please, I need a VM, please set me a VM, and it takes time. Better use of resources, almost unlimited environment, faster deployment time, simplicity, it's only templates, both upload the Kubernetes and uploading those sites. It's just one template that we are editing and deploying. If it's not working, blame the developer now. So in the previous setting we had, because of few moving components, as lack of knowledge of how the Puppet run, and it's on a Ubuntu VM, and we are not in a VM, so the many came to us that something didn't work, and now, as I said, now the blame is on probably something wrong with the code and not with the container themselves. Sorry. Challenge 2 is the QA automation. And in QA automation, we're simulating the client behavior. And here we receive few facts, few given fact that this is what you need to work with. and find a better solution than we have now. So simulating client behavior is we need variable number of VMs for different runs, 100 of tests, Windows operation systems on VMs. This is the code of the automation works on that. And we need to make it cost effective and fast. And for that, we choose the Azure VMSS solution. VMSS is a virtual machine scale set. It's managing a group of identical load balanced VMs with elastic out of scale. It's easy to create and manage multiple VMs. Also, everything is with templates. It provides high availability and application resiliency, dynamic and large-scale support, and it's automatic because of the templates that we say. The QA automation flow, again, it starts with Jenkins. Here we are, again, deploying a template that will create the VMSS cluster. Okay, only one template that we are setting. The number of VMs is set by the number of scenario tests that we want. It could be 1, 2, usually between 70 to 100 scenarios simultaneously. So this is the scale of the cluster. On those clusters, we have actually what image is not a plain vanilla image. It's a custom image that we made. That inside it, we have already installed a Swarm plugin of Jenkins. That when the VM is up, each VM by itself, we have a startup script, a feature of that scale set. And that startup script start this plugin on those servers. Those servers connect the nodes with what is the master and just connect to the master, and we have a new Jenkins slave. All of those slaves are labeled with the same label, as already know, everybody familiar with Jenkins. So we label them with the same label, and when the job is running, it just choose the new available VM that just came up. It's not all the VMs that came up in the same minutes or second. It's gradually. So each VM received a new scenario of test. We download the test code to each VM simultaneously. We have the test. Before we destroy, of course, we need to see what happens. So we aggregate all the test results to a static server that we are not destroying, and not part of the cluster. It's a Diffido server. It's a third-party company that developed Diffido, and it's you can get it on GitHub as well. This tool is aggregate all the reports and test results to one place that we can check afterward. And when we finished, each job finished its run, we destroy VM, and at the end, the cluster is down. And this is the cost-effective point. This is few print screen charts from the Diffido server when we're done. Of course, you can put the results because it's a log file. You can integrate them inside a pipeline, a CI pipeline, and you can choose to run not the entire automation, only 1 or 2 tests that is crucial for you. And if it's success, you continue with the pipeline. If it's not succeed, you fail. And this is what we managed to do. While we were growing, we have more and more and more automation, and we reach out that running the entire scenario with all end-to-end test, we reached 26 hours for one server, on one server, to 1.5 hours for a cluster. And now just to say, when you choose a VM in Azure, you can choose the scale of the VM. As it's not always a matter of pay more, get more expensive VMs with more of them, and you get faster, or choose low cost but more of them. Okay, what I mean? Not the high performance server that costs a lot versus low resource server that costs little. you need to find the right balance for you, for your test, for your or set of tools inside this automation. We found out this is something in the middle. We didn't choose, of course, the lowest price and the lowest resource server, but we also didn't choose the more expensive one, because then we'll have a few other bottlenecks. So here we reach to production. We got the manual test, or for each developer, we have documentary, and now we have production readiness. So production readiness, again, some given facts. We don't know how many VMs we need for each application. Okay, know that. Move from classic cloud service. Everybody familiar from the classic cloud service in the ASM, Azure? So we need to move from that, and as easily and fast as we can. And because we are also a .NET, the best solution and faster solution for the entire company is, again, going to VM. Okay, again, we can't go Kubernetes, so we stick with VMs until we get the .NET Core ready. Make it cost effective, redundant, and resilience. Scale in and out, of course, because we are in the cloud. If we're not scaling in and out, so why bother? It's not that cheap, the cloud. If someone told you it's cheap, it's not that cheap on those scales. And of course, self-service is possible. And again, surprise, we choose the VMSS. I can't say this is the best offer in the market, of course, but this is the best solution for us, and this is important. Okay, when you choose a solution, don't go to Kubernetes because everybody goes to Kubernetes. If it's not ready for you, if it's not suitable for you, you need to match the business goals, and that's why we choose VMSS. So this is a flow. I'll try to explain it a little bit. Again, our little friend here, Jenkins. Say hello again. And what we are doing, we are pulling all the templates of the VMSS from GitHub. We are saving that as a code. Few other upload artifacts after the build to Artifactory. Then we deploy the Azure AZ templates to Azure. We're creating the VMSS. Remember the startup script? Again, here we have another startup script. When the VMs on those cluster are up, we start the startup script. What the startup script is doing is pulling from Artifactory, J for Artifactory over there, yeah, the Puppet MSI. We said before, we're using Puppet MSI. We bring that Puppet MSI, we installed it. Now we know in which environment we are because we use the template we pull from GitHub, and we trigger the Jenkins pipeline, so we know where we are. So the Puppet has been configured using this startup script, and it knows which is master, and what the name of application, and what other configuration you need to do on the server. And once the VM is ready, the startup script initiates Puppet run command with its Puppet agent -t. It's pulling everything from the Puppet master server, the catalog, and then the server is ready. If everything goes well, it's ready, and you can notify the system, which we'll see immediately, I'm ready to work. This is example of a template that we have the admin user and the password you can put, and the Artifactory location, service name, etc., etc. You can put it in GitHub if it's not credentialed and so, and you can send it as a parameter from Jenkins. And this is how the multi-region architecture looks like. We talk about resilience and redundant. So as you can see, it's quite big. We have here at the top the load balancer, and in each pool he has one region here, one region here. We have 2 clusters on each region. Not that cost effective, but we'll see how we deal with that as well. Why we are using two clusters in each region? The idea is to make sure we can do canary test, deploy with avoiding interface with the clients, have a downtime. So we have 2 regions, two clusters in each region, and we tag them with blue and green, that you probably heard the terms in other sessions as well. So when you're deploying a new a new code. So we have in one region, let's say West, we have build number 9 on VMSS cluster 1 and build number 8, the previous one, on the blue one. And here, again, on the other side. So in each given time, we have only one cluster running on each region, not two. Okay, this is a normal production configuration. Once we deploy to the blue. Our Azure CLI script is checking which cluster is tagged with the name blue, okay, status blue, and okay, I'm going to deploy to that cluster and to the other cluster. Once we finished, now this is the state. On the green one, VMSS 1, we have build number 9. Now this is the previous one. On the green, we have 10. You can tag your cluster, which I think there is no limit on the tags, and you can use those tags to choose what you want to do. Just query those tags. And this enables us another good solution for rollbacks, a quick rollbacks. We can deploy that, okay? And we can wait 1, 2, or hours, days, I don't know, it depends on your application. And if everything goes well, we'll shut down the blue cluster and we get the cost-effective goal that we need. But if something goes wrong and we understand that it's a bug, something with the code, so we can just change the tags. You can do it with a script, of course. You can do it manually using the site, and we're back. Okay? And this is a matter of milliseconds. The time it takes you to log into the Azure and go to the tag and change is slower, will take more time than the switch between those clusters. Again, the benefits, large number of VMs. I think the limit is 100 in one cluster. Repeatable deployment, easy rollback. Faster deployment times, we were able to decrease the time in cloud services. It took us 14, 20 minutes sometimes to 7 or 5 minutes. Cost effective, of course. Sorry. Ignore that. Okay, it's slow. It's slow at the end. Faster deployment, we said that. Cost effective. We keep the current configuration of production. Infrastructure as a code. Everything is in templates. We're doing almost nothing manually. Everything is using the Azure template. And I know there was another one. Never mind. So this is the end. We reached our 3 goals. So thank you for listening and having me.